In this video, we're going to cover the first three learning objectives, A, B, and C, where we're going to talk about stating in words how a translation rule impacts a graph, then actually stating the translation rule of the ordered pairs, and then translating data points using that translation rule. So let's first talk about back in geometry, when we had an ordered pair on graph paper, and you wanted to take this ordered pair of x, y, and you wanted to move it, let's say, a units to the right. What variable gets impacted, the x or the y? And then how does it get impacted? Would you add a to it or would you subtract? Well, in that case, if you just remember the x-axis and the y-axis, which axis moves how? So the x-axis moves left and right. So to move anything left and right, you are going to impact the x-axis. So we know for number 1 and number 2 is left or right, so it's the x. Now, what about up and down? Well, the y-axis is the one that goes up and down. So whenever you want to move something up or down, you're going to go to the y-axis. Now, in the ordered pairs, you're literally going to move that way. So what's going to happen to the x's if you move right? Well, right is a positive movement, left is a negative. So on that, you're just going to say it's x plus a, and the y's stay the same. If you move left, you're going to go this direction. So that's x minus b and the a. Now, on the y-axis, if you go upward, that's a positive y's. If you go down, it's a negative. So same thing. If I want to move up c units, x stays the same, but it's y plus c. If you want to move down d units, it's going to be x stays the same, and it's y minus d. These are called translation rules, and it tells you how the ordered pairs of your picture will actually move. Now, what is a translation? The best word, is it a reflection, a slide, a flip, or a stretch? Well, when you translate, notice this. Do you see the SL in the word translation? Same as the word slide. That's a good way to remember it. So to translate means to take a graph from its parent function and to slide it either left, right, up, or down. So a translation rule in the plane is a transformation that maps at the point xy onto the point x plus h and y plus k, where h and k are the constants. Now h just means it's the x movement and k means it's the y movement. Okay, some vocab we need is, what is a preimage? If they say preimage, they mean it's the original graph that they gave you. If they say the translated image, it's the graph after you did the translation. So here's what they want us to do. Identify the preimage and the translated image. So you just have to look carefully at the picture, because it's not necessarily that this f function, which is the square root of x, was the first one, and the second one is square root of x plus 3. But if you notice, there's this little arrow. So look at the picture. So they're going from the blue to the red graph. So the preimage in this one is f of x equals the square root of x, like we thought. The translated image is g of x equals the square root of x plus 3. So then they want to know, well, what's a translation rule? Well, here's how we tend to write it. We tend to say T for the translation of the ordered pair x, y. We do that because in a later section we're going to do a scale change and we change the T to an S. So we translate x and y. What do we do to the x's? Well, if you look at these ordered pairs here, they've given us some ordered pairs. What happens to the x's? This just says this is the ordered pair 1, 1, and then 1, 4 on the next one. And this is the ordered pair 2, square root of 2, and then 2, square root of 2 plus 3 on the next one. So what I'm looking at, if I look at the ordered pairs, how did the y values change from the first graph to the second? Well, they added 3. Or you can just look at the graph. What I will do is actually identify the starting point of this parent function, which is right here, and then I look and see where that point moved to right there. And I just count. It actually slid up 3. So it slid upwards, so that means it's not an x movement, it means it's a y movement, and this would be my translation rule. Okay, let's look at a graph. The graph of y equals x squared, which is the parabola at the right, is shown with its image under the translation. I'm going to actually sketch this image, so let's look at it. It says the point 0, 0, which is the vertex of this graph, maps into the vertex of 2, negative 5. So let's graph 2, negative 5, which is right here. That's the new vertex of it, so we'll just do a quick sketch. And I'm going to label 2, -5. Now, what they want us to do is find the translation rule. So for part A, here are the 4 choices. What's actually happening? Again, the easiest way to do it is to take the key part of the parent function that we started with, or the preimage, which is 0, 0, and see where it ends on the new graph, which is right here, and just travel and see what happens. So to travel there, we actually moved right 2, down 5. So for that, I'm going to say right 2 would be plus 2 to the x's, down 5 is minus 5 to the y's. And if you look at that, you're going to see that is option B. So that is the translation rule. Okay, part B wants us to actually move an ordered pair from that blue graph. So it says, find the image of 3, 9 under this rule. Well, the image 3, 9 on the original blue graph is sitting right there. So they're saying, where's that going to move to? Well, I technically could either go right 2 and down 5 and actually travel and see, or even easier, I could just do this. That 3 is the x, the 9 is the y. So how do you know what it is? Just put 3 in for x, put 9 in for y. So that would say it's 3 plus 2, 9 minus 5. That ordered pair should move to the ordered pair of 5, 4. So let's take a look. The ordered pair 5, 4 is about right here, so it looks like my graph should be just a little bit more steep right there. So if I did a better graph, 5, 4 would be right there, and that's where the image moved to. Let's actually do one more question on here and talk about what is the range of the new translated image or the red graph. Remember domain and range. So the range is the y values. So on here, I would say the range is all the y's that are greater than or equal to -5, because the red graph doesn't start till the y's are -5 and then it continues to go. Okay, let's come up with the translation rule for this. What if the original ordered pair is 0, 0 and then they move to 7, 8? How did it differ? Well, the translation rule of the xy ordered pair, what they did is they took the x's, they went from 0 to 7, so they added 7. The y's, they went from 0 to 8, so they added 8. So in words, what would you say that they did? Well, they moved right 7 and up 8. Okay, part B, find the image of where 6, -10 would move to under this translation. Again, this is just the x, and that's the y value. All you have to do is put them in for their corresponding values and see what you get. So here it would be 6 plus 7, and it would be -10 plus 8. So that ordered pair is going to move to 13, -2. Okay, let's do another one. On here, we are looking at what is the parent function or the preimage, what is the translated image, and what's the translated rule. So if you take a look at it again, you can tell that they're starting with the blue one because of this arrow. They're taking the blue center and they're moving to the red. So the parent function or the preimage in this case is the x squared plus y squared equals 25. Well, what's the translated image? That's just the other equation. It's x minus 10 squared plus y plus 2 squared equals 25. Now, they just want to know the translation rule. So if I want to, I can just go to the graph, find the center, which is at 0, 0, and just see how they moved to get to the new center. Well, what they did is it looks like they moved to the right 10 and down 2. So to the right 10 would be x plus 10. Down 2 would be y minus 2. Again, we're not to the equations yet, but I want you to make this connection now. The translation rule literally says the graph move right 10 and down 2, and we can tell that. Well, how would you make an equation do that? What you would do is you would take your preimage or parent function, and you're going to apply the translation rule. And notice what we see. The ordered pairs said, hey, I'm going to go plus 10, but in the equation they did x minus 10. Again, the ordered pairs for the y said y minus 2, but in the equation they did y plus 2. So to force an equation to move the way we want it to, you would take the translated rule and do everything in the opposite direction. That's what this rule is telling us, and we're going to focus on when we look at the equations next. Okay, let's do another one of those with a graph. Again, they want to know the preimage or the parent function. We can see by the graph the preimage or the parent is y equals the square root of x, which looks like its absolute value in a V shape. The translated image is going to be y equals the square root of x minus 4. So what was the translation rule? Well, just take the vertex of the blue, travel to the vertex of the red. All they did here is they moved right 4. So in this case, it was just x plus 4 and nothing to the y's, and that's the translation rule. Now, before we get into the equations, I do want you to see this connection. Notice the equation that they wrote for the image. It's x minus 4. What really happened in the graph, though, is it moved x plus 4. So what we're going to notice is to make an equation actually do what we want for the x's, instead of doing plus 4, which is what really happens to it, in the equation you must write the opposite of that, which is minus 4.